Hello students, now I am going to discuss about isomers. Isomers. From this video you can learn what is isomers and how you can draw different isomers of a compound and their names. First of all, what is isomers? Compounds having same molecular formula but different structural formula or displaced formula are called isomers. That means if some compounds have same molecular formula but their structural formula are different or displaced formula are different, these compounds are known as isomers. Isomers, compounds having same molecular formula but different displaced formula are called isomers. Important point, same molecular formula but different structure formula or displaced formula are called isomers. Compounds having the same molecular formula but different structural formula are called isomers. Now you see butane, C4H10, you know this is an alkane, C4H10, this is an alkane. So alkane, butane has two isomers, one is butane, this is butane, and other is 2-methylpropane. That means butane has two isomers, one is butane, other is 2-methylpropane. Now how you will draw? You see, at first here you see C4H10, so you write 4 carbon, 4 carbon, then carbon valence is 4, you know, so left hand carbon has only one bond, 2, 3, 4, and this carbon has 1, 2 bond, need 2 hydrogen, 2, and this carbon has 1, 2 bond, so needs 2 hydrogen to fulfill carbon valency 4. Right hand side carbon have only 1 bond, so need 3 hydrogen. This is butane 1, you can give this hydrogen, 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 10 hydrogen, so this is butane. Now you see this compound has molecular formula C1, 2, 3, 4, C4, H3, 5, 7, 10. So butane has molecular formula C4H10, and you know what is molecular formula? Molecular formula shows the whole ratio of atom. Butane has 4 carbon and 10 hydrogen. Now you how you can draw another isomers of butane. You see here 1, 2, 3, 4, long chain 4 carbon. Now you write 3 carbon, 1, 2, 3. Then other carbon you will give here as a branch, and you remember in left hand side or right hand side there is no branch always in the middle. So here 2, 1, 2, 3 carbons, so this is the branch. Now you give hydrogen 1, 2, 3, this carbon 1, 2, 3. So 1 hydrogen needed. Left hand carbon 1, 2, 3, 4. This carbon 1, 2, 3, 4. Here also 3 hydrogen needed. So this 1, 2, 3 carbon, 1, 2, 3 carbon, 3, 3 carbon alkane is propane, so this is propane. But number 2 carbon contains 1 methyl group, and CH4 is methane, so when 1 hydrogen is removed, it forms CH3. CH3 group name is methyl group. So number 2 carbon contains 1 methyl group. This compound name will be 2-methyl propane. Why propane? 1, 2, 3 carbon. Long hydrocarbon, long chain, 3 carbon. This is propane. But second carbon contains 1 methyl group. So this name will be 2-methyl propane. Now you see 2-methyl propane, how many carbon here? 1, 2, 3, 1, 2, 3, 4 carbon. 4 carbon. Hydrogen 3, 6, 9, 10. So butane and 2-methyl propane, these two compound has same molecular formula, mean C4H10, but their structure or their display is different. So butane and 2-methyl propane are 2 isomers of C4H10. It's clear to you? Next, you see pentane, C5H12. Pentane is also an alkane. 5 carbon containing alkane has 3 isomers. One is pentane, other is 2-methyl butane, and third one is 2,2-dimethyl propane. 2,2-dimethyl propane. So how you draw? At first you draw as C5H12. This is pentane. This means this hydrocarbon contains 5 carbon, 12 hydrogen. Molecular formula is C5H12. So first you write here 1, 2, 3, 4, 5 carbon, pentane. Then you give hydrogen, this C5H12 to 12 hydrogen. So left carbon 1 bond, 3 hydrogen needed, 3 hydrogen to become carbon valency is 4. Carbon is a group 4 element, so its valency will be 4. That means carbon always form 4 bond, and you see this 1, 2, 3, 4 bond. This carbon 1, 2, 3, 4. Also number 3 carbon 1 bond, 2 bond, 3 bond, 4 bond. This also number 4 carbon 1, 2, 3, 4. Number 5 1, 2, 3, 4. So this is pentane, and second one is 2-methyl butane. So how you will do? And you will give 4 carbon, 1, 2, 3, 4. Number 2 carbon you can give a branch here, methyl, 1C. So 1, 2, 3, 4, 2 methyl, this name will be 2-methyl butane. Why butane? Because 1, 2, 4, 3, 4, 4 carbon, long chain hydrocarbon is 4, and one number 2 carbon contains one methyl group. Methyl group means CH3 group. And if you count it from right hand side, this is the 2. If you count from left side, 1 2 3. So if you count from right hand side, this is the smaller number 2, so you count from right hand side because to get a smaller number, that's why 2 methyl butane. But if you count it from left hand side, this will be 3 methyl butane. So 2 is the smaller number than 3, so to correct answer will be 2 methyl butane. And number 3, you see now 1 2 3 carbon containing alkene is propane, but number 2 carbon contains above 1 methyl group and below 1 methyl group. So this name will be 2, 2 dimethyl propane. Dimethyl why? Because number 2 carbon contain 2 methyl group. That's why this name will be 2 dimethyl propane. 2 dimethyl propane. Second carbon contains 2 methyl group. 2 dimethyl propane. Now you see pentane, this molecular formula will be C5H12. C5H12 and 2 methyl propane also molecular formula C5H12. And 2 dimethyl propane also have 5 carbon 12 hydrogen, C5H12. So pentane, 2 methyl butane, 2 dimethyl propane. 3 compounds have same molecular formula, but their displayed formula is different. So these 3 compounds are 3 isomers of pentane. You know what is isomers? Same molecular formula but different structural formula or different displayed formula. Now this is the isomers of alkene. I showed earlier isomers of alkane. Now alkane, and you see butane is a alkene, has 3 isomers. One is 1 butene, 2 butene and 2 methyl propane. So how you draw? You see 4 carbon, C4 butene formula C4H8. So 1 carbon, 2 carbon, 3 carbon, 4 carbon. As it is an alkene, so you have to write 1 double bond. So 1 double bond I write here. Then right hand side carbon contains already 2 bonds, so 1 hydrogen, 2 hydrogen. And this carbon 1 2 3 already 3 bond have, so 1 hydrogen needed to be 4 of carbon valency. And third carbon 1 2 1 hydrogen, 2 hydrogen. Left hand carbon need 3 hydrogen. So now this will be 1 butene or 3 butene. This will be 1 butene. Why? If you count from right hand side, this is the 1 2 3 4. Double bond contains number 1 carbon, so if it will be 1 butene or but1n, same thing. Or if you count from left hand side, 1 2 3 4, but3n. So 1 butene and 3 butene, 1 is the small number, so we have to count from right hand side, 1 2 3 4. So this is the correct. we count from right hand side, or you can write here double bond is here, no problem. In that case no hydrogen will be here, this single bond, this hydrogen will be here, 1 butene or but 1N. Now but 2N, 4 carbon, 1 2 3 4 number. If you count from left hand side, 1 2, double bond contains second carbon. If you count from right hand side, 1 2, so same thing, this is 2 butene or but 2N. This is the isomers of alkene. And you see number 3, 1 2 3, here double bond, this is the propene, 3 carbon containing alkene, name is propene, but second carbon contains 1 methyl group, so this name will be 2 methyl propene, or you can write simply methyl propene, you get mark, no problem. So this is, if you count here 3 carbon propene, number 2 carbon contains CH3 group, CH3 is means methyl, so this name will be methyl propene or 2 methyl propene. This is, so now you see these 3 compound have 1 2 3 4, C4 H3 5 6 7 8, C4 H8, and this also molecular formula C4 2 methyl propane